What did I just draw up there? That green line is a tangent. How do you know it's a tangent? Because it intersects one spot. All right, let me introduce you to another vocabulary term. What about a line? A line that intersects a circle in two spots. Two spots. You want to take it? How do you say that word?
Secant.
Good job. It's not French. It's not secant, like a croissant. All right, secant. All right, secant. A line that intersects the circle in exactly two spots. I wanted to introduce that because you're going to see a lot of secants drawn today. A lot of secants. Real quick review. You guys are familiar with three angles inside a circle. They are central, inscribed, and yesterday, floater. Now we got to talk about what if an angle is formed outside the circle. How do I find it? So everyone look at my three types of diagrams here. Diagram one. Angle B is formed by two what here? Two tangents. Thank you. Angle B, two tangents. Angle A outside the circle formed by a, what's AB? Tangent and ACD? Secant. Good. And angle A formed by two secants. All three form an angle on the outside of the circle, but all three are found the same way. All three angles are found the same way no matter how they are formed. And here it is. Angle on the outside of the circle. Angle on the outside. Here you go. Angle on the outside. Anytime an angle is on the outside of the circle, this is how we're going to figure it out, no matter how it's formed. We're going to do the difference. Ooh, let's stop right there before I move on with this formula. Difference, so we're going to be doing what operation? Subtraction. We're going to be doing subtraction. What are we going to be subtracting? The difference of the arcs in between. The difference of the arcs in between. Oh, I'm not done yet. And then we're going to do the same thing we did the floaters yesterday, which was, what did we do after we added them yesterday? We're going to divide them by 2 again. Yep. But now we're going to subtract them. We're going to subtract the arcs in between. Just so I know we got a handle on it before I go to something new, take a look at my third diagram. Angle A is the angle outside. Angle A. So I just want to make sure we're clear. What 2 arcs would I be subtracting here before I divide by 2? What 2 arcs? Again, it's the arcs in between. And again, you always want to put the bigger one first. Why? You put the smaller one first, you're going to have a negative angle. And not this year, next year. All right, so what 2 arcs would we be subtracting here? What would be the first arc I'd put in here? CE. That's the first arc. Everyone see what I mean by in between? Inside it. So arc CE. And I'd subtract from it arc. What's the smaller arc in between it? BD. Good. I just want to make sure you definitely have a solid handle. Let's go over this first diagram. Angle B is the angle on the outside. Tell me what 2 arcs I should be subtracting here now before I divide by 2. What's the bigger arc? Which one? All right. That's why the D's there, right? CDA. And then I'd subtract from it arc CA, yes. All right, so everyone all right if an angle's on the outside? All right, so we got an angle on the outside. I just reviewed with you 3 angles on the inside. Are there any other type of angles you might see? What if it's not inside? What if it's not outside? Well, what else is there? All right, what else is there? Could be a half and half. Could be a half and half. What do I mean by half and half? Half of it's on the inside, half of it's on the outside. And you can make fun of me all you want, but I have a special name for these types of angles where it's a half and half. I call them tweeners. Tweeners. Why tweeners? It's like a between angle. It's not really outside, it's not really inside. It's kind of in between. Tweeners. And you guys don't have 140 on there. Let me get rid of that real quick. Why do I call this a half and half, a tweener angle? What's BA? Chord, which is inside. And what's CA? That's a tangent, which is outside. So that's what everyone see why it's not inside, outside. It's half and half, a tweener. All right, there's two types of tweener angles. First one, you guys just answered this for me, formed by a chord and a tangent. An angle formed by a chord and a tangent. So angle CAB. All right, angle CAB. How do you find a tweener angle formed by a chord and a tangent? You take half the arc in between. Come on, I can spell today. Okay, I'm going to take half the arc in between. So for angle CAB, I'm going to take half of arc, minor arc AB. Okay. The other type of tweener angle you'll see, the other type of tweener angle, formed by a, what's BC again? Chord and ACD. Now we know that's called a secant. So this, make sure you make a little note here. It's this angle I'm talking about right there. How do I find that angle? Formed by a chord and a tangent. That's the other type of tweener. And you're not going to like this at all. You're not going to like this rule. Because there is none. I don't have one for you. It's not like take half of this. It's not like add these together and divide by 2. But I'm still going to ask you to find it. How can you do that to us if there's no rule? How do you find that angle? There's no magic formula or rule for it, but how do you find it? Take a look at the whole diagram. How would you find that angle? Find the, what type of angle's right next to it? Oh, what type of angle? It was BCA. That's called a? Oh, just BCA. Just BCA. Inscribed. That's an inscribed angle. You know how to find those. And then do what to find the BCD? Subtract it from 180. So you can find it. I just don't have something that says take half of this, add these together, divide by 2. I don't have that for you here. It's just find the inscribed angle and then subtract it from 180. All right, so that's it. Central inscribed floater. Angle on the outside, 2 tweeners. I have given you every angle you could possibly see in a circle. Every angle you can now find. Now it's just a matter of, let's practice this. Numbers going. All right, let's have a little fun here. Let's find angle CAB. First question I'm going to ask all of you today. All of you, everyone's going to ask the same question first. Inside, outside, tweener. Or I guess you call it half and half if you don't want to use my tweener. All right, so angle CAB, what type of angle am I dealing with? Inside the circle, outside the circle, or a tweener? What type of angle is that one going to be? Oh, 10. Let's start us off, Matt. That's a what? Darn right. Thanks for using that. Yeah, 2. It's a tweener, right? So it's one of 2 types. It's either chord tangent or it's a chord secant. Matt, what type is this? Chord and a? That's one I got a rule for. That's one I got a rule for, Matt. So I'm going to take half of, what's the arc in between it? What's its measure? 140. There you go. Good job. 140. So I'm going to take half of 140. That tweener angle 70 degrees. Good job, Matt. All right, over here, 160. I got to find minor arc. Ooh, hoo, hoo. Minor arc. Make sure we're finding this arc, not the other one there. Minor arc, AB. Can I get a show of hands? We got to make a class decision. And the decision is going to be, do you want to use the 160 or do you want to use the angle next to it as a class? Because we could go 2 different ways to solve this. Do you want to use the 160 or do you want to use the 20? Or the one next to it? How many people want to use the 160 and just go from there and find the arc? How many people want to use the one next to it? Sure. All right, here we go. You guys are really involved here today. So I'll use the 20. All right, what type of angle is the 20 then if you want to use that? Inside, outside, or is it a tweener? Ian? Darn right, it's a tweener. All right, is that formed by a chord and a tangent or a chord and a secant? Okay, so I got a rule for it. All right, now, but do I take half of 20? I double it. Yep. So minor arc AB. Going to double it. 40 degrees. Everyone all right with those tweener examples? All right, let's go to number 3. What type of angle am I looking for? Angle X, inside, outside, tweener. What type? Charlie?
Outside.
It's outside. So I don't have any more questions. If you tell me it's outside, there's only one way to find it. Subtract 2 arcs and divide by 2. It doesn't matter that this is 2 secants or if it's a tangent into secant. Charlie says it's outside. Done. Here's the rule. All right, now I have to subtract the 2 arcs in between it. What are the measures of the 2 arcs in between it? Ian, back to you. What are the 2 arcs in between? 90 and 20. Make sure we subtract the first one, obviously, first. The bigger one first. So we don't get a negative angle measure. So we're looking at 35 degrees here. I'm going to skip over to number 5. We are going to go back to 4, but 4 is a beast. I think if I do 5 with you, it's going to help you with 4. So let me do 5 with you. 60 degrees, 60, inside, outside, or a tweener. What type of angle is it? Go in here. Thomas, what type of angle?
Outside.
It's outside. So that means that 60 was found by taking 2 arcs, subtracting them, and dividing by 2. But we run into a little honors problem here, right? The bigger arc is not given. The smaller one is, everyone all right? I'm going to put minus x. That's the smaller one. I need your help, though. How can I find what this bigger arc measure is then? Right? That's what I need to find. So I can put it right here. Well, these 2 arcs add up to what?
360.
Right? Everyone, yes? 360, those 2 arcs. Whole circle, 360, those 2 arcs. Well, this one's already x. So how can I write what that bigger one is, that blue one up there? 360. Not just 360, but 360. Well, how about this? How about this? I know some people, I can't see this right now. Let me say that, and it's not true. If that was 100, how are you guys going to find that bigger one now? What would you do? You take 360 and subtract 100, right? Well, it's not 100, it's x. So instead of subtracting 100, I'm going to take 360 and subtract x. 360 minus x. That's the arc that's going to go in here. So bigger arc, 360 minus x, minus the smaller one, x. And we did this yesterday, but just a reminder, how am I getting the 2 out of there? Multiply by 2, good talk. Yep, multiply by 2, and then you guys can finish it. I'll ask somebody the answer here in a second. Make sure you combine your like terms. When you do have that answer, let me know. Take your time, though. Let me know when you have it. Josh, when you have it.
X equals 120.
Oh, great job. Great job. All right, let's go to number 4. Use what we just did on number 5 with number 4 now. Use that. Use this technique that we just used. All right, 38. First of all, where's 38? Inside, outside, or is that a little tweener action going on? Matt? That's outside. Thank you. So we know we're going to subtract arcs. So I have 38 equals 2 arcs plus you subtracted. Everyone's all right? The smaller arc's x again? All right, what about this other arc in between now? How about that one? No, not 360 minus x. No. Well, we already know that one's 140. Take that away. How much is left now? I had 360 to work with, but I had to take away that arc of 140, and how much is left now for these 2? 220. Again, now we can play like we did on number 5. If that's x, the rest of it's got to be 220 minus that arc. Okay? And then go ahead and multiply both sides by 2. Do your thing. When you're ready, let me know. Will, when you have it, let me know. 72. Whew. All right. So I think we're good. Inside, outside tweener. Now it's time to put it all together. I know you were hoping for one today, so I want to produce. Here we go. King size. A reminder from yesterday's class, what's going to make us successful in the king size if we will do what first, if we can? Find all the arcs. So I'm not, who cares about A through F up there? Nobody cares. Nobody cares. Let's try to find all the arc measures first. All right, so let's see. What do we got? Ooh, CD's a tangent. Perfect. There's that secant word today. I like it. ABC. Ooh, hey. AB and AD are congruent. Can I ask a vocabulary question? What are AB and AD in that circle? Those are two, what? What do we call AB and AD? Chords, right? This is day one, right? Chords. Those are chords. And arc AB is 150. I'll label my diagram. Make sure it's AB, the minor arc, right? 150. Guys, wait a second. There's got to be some reason I gave you this. I just don't throw things out there to say, you're not going to need me. Everything I give you is always used. So why did I give you that those two chords were congruent? You got a fact for me, Josh, you're going to use?
Congruent chords have congruent.
Day before break, we went over if two chords are congruent, so are the what again, Josh? The arcs. All right. So this is why I told you. Because if AB and chord AD are equal, that means their arcs AB and AD are congruent. All right. The arcs are also congruent. All right. We're going to find all the arcs. I guarantee it here. What's one other arc now? Now we know what other arc. What's another arc we already know now? Now that we just went over that fact. AD also has to be 150. So here we go. AD is 150. All right, you're going to find the rest of them now. Ready? I'm going to start with arc EA. I'm going to go right around the circle. Arc EA. Think about it. Don't overthink it. Why 30, Ian?
If that's 150,
yeah.
The side has to be 180.
EOD is the diameter. I don't look for that all the time. All right, we got to start. If EOD is a diameter, I got two semicircles measuring 180. All right, there's EA. I'm moving on now. How about arc EB? Don't overthink this one. Arc EB. How many degrees in arc EB? Don't overthink it.
120.
120. Why 120, Josh?
Because 150 minus 30.
I gave you at the beginning of the problem, arc AB was 150. Part of it was 30. Well, the other part's got to be 120 to add to 150. And then finally, let's finish this on a strong note. How about BD? Arc BD. Should be 60. Why 60, Zeev?
Because all of them have to add 360 and 360.
I could do all of them have to add to 360, or I could do the 120 and that one had to be a semicircle. Either way. All right, let's have some fun. I'm going to call in 5 different people right now. Five different people to figure out parts B through F. Why don't I call on anybody for part A? We already did it. Arc AD we already found was a 150. First thing I want you to tell me if your number gets called, inside, outside, or a tweener. Angle BAD. Here we go. Part B, angle BAD. Inside, outside, or a tweener. And I'll show you how my thinking goes, and hopefully your thinking will as well. Oh, here we go, Aiden. Inside, outside, tweener. Okay, if you say inside, then you ask yourself the following question. Ready, Aiden? Is it central?
No.
Inscribe.
Yeah.
Okay, we're done. There you go. If you tell me inside, it's got to be one of the magic 3 we talked. So half of, one more job here, Aiden. If it's going to be half an arc, what arc measure is it connected to, BAD? 60 degrees, good. So half of 60, 30. What did I recommend yesterday too after doing each part? Label it in your diagram because you might not have a fact and you might have to rely on some geometry. So 30, make sure we put 30 in for angle BAD. Aiden, great job. Let's move on now. Part C, the measure of angle ACD. Inside, outside, tweener. What am I working with? Ooh, going deep. Zeev, what type of angle am I working with? Inside, outside, or a tweener?
Outside.
Outside, yeah. I don't have any other questions for Zeev because I know he's going to subtract 2 arcs and divide by 2. All right, take your time here, Zeev. What is the bigger of the 2 arcs in between angle ACD? 150 minus the smaller arc in between it?
60.
Got it. Oh, this is great. This makes you know every single rule we have here. 45? Label it. 45. All right, you guys are doing a good job so far. Part D, measure of angle EFB. Inside, outside, tweener. EFB, where is it? 8. Here we go, Josh. Where is it?
Wait, which one?
EFB, part D.
Oh, it's a floater.
Okay. Inside float. Fine. Yeah, you got right to it. Floater. That's yesterday. Now I add 2. Ready, Josh? What arc is connected to EFB?
Arc EB.
120. Yep. Now look at it. Now look at the vertical angle to EFB. What arc is connected to the vertical angle?
Wait, what's the question?
EFB. Got that angle for me? Vertical angle. What arc is connected to the vertical angle?
Oh, AD.
Yep, 150. We got it. That's a big one, huh? 135. Label it. All right, we're almost there. 2 more. Part E, angle EDA. Inside, outside, tweener, EDA. Aiden already went. Great job back in the day here. Amy.
Inside.
Inside. All right, here we go. Central.
No.
Inscribe.
Yeah.
Take half. What's the arc connected to EDA?
30.
30. EDA, 15-degree angle. The last one, I'm going to need a stud for this one. I'm going to need a stud. So some of you might want to leave right now. Angle EDC. Whoever's number comes up, I'm not going to ask you a single question. I don't want to know if it's inside, outside, or tweener. Because there are 3 different ways you could find angle EDC. 3 different ways. One of them is using no circle facts. No, you don't even need any circle facts to find EDC. That's one way. But there's 3 total, so I'm just going to let you do you. All right, I don't care if it's inside, outside, tweener. You tell me how you want to find that angle in your own words, in your own style. I still need that. All right, here we go. Who's up? All right, we ready to roll? Thomas, how you going to find it?
CD is a tangent and OE is a radius.
So he's going to use our fact that says when a radius and a tangent meet at the point of tangency, what happens?
That's right.
That's one of the 3 ways. Remember I said there's a way to do it without using any circle facts? Here you go. 135, you can find the angle adjacent to it, can't you? 45. And then everyone see this little, where am I going to use? I'll use some gray. This triangle right here. 45, 45. Oh, 90 left over. And did anybody do the 3rd way, which was that's a tweener angle formed by a tangent and a chord? So you would take, ready, watch, half. I'm running out of colors. You would take half the angle in between, which ended up being a semicircle. So you would take half of 180. So there's 3 different ways you could have done it. Anybody do a fourth way where they found Steve?
I did ACD.
I was going to say, to use that triangle, then subtract 15 from 105.
Yeah.
Yep, there's a fourth way. Questions? Anything else? All right, I want to see you do this next one on your own. I got this off an old Regents exam, not that you care, but good story. Find angle P.
Do you have to write out all of those equations, like on the quiz?
I'd like to see how you got it, yes. Yes. Because there had to have been some kind of calculation involved.
Yeah.
All right, just to make sure we're good here, everyone took arc EZ minus arc LZ divided by 2. You had LZ was 56, but you had to find EZ on your own. Hopefully you noticed that was a diameter, EKL. So you subtracted 56 from 180 and got 124 for EZ. And then subtracted divided by 2, angle P, 34 degrees, everyone. 34.